All right, miraculous physics and creation. Okay, what we're going to go through tonight is we're going to talk about Hebrew words and the Hebrew and the narrative and the first chapter of Genesis and the 6 days of creation, an outline of that. We're going to talk about Dr. Faulkner's Dashet theory, waves of rapidly maturing creation as he sees it, and some kind of transition from creation to sustaining, as I mentioned a little earlier. We're going to talk about Big Bang physics. Whenever you see Big B, BB, that means Big Bang. It's so commonly used. Okay. We'll look at the fact that extrapolating back to creation from the present things we can observe just doesn't work. I'll show you why. We'll look at Carmeli, Dr. Carmeli and Dr. Hartnett's white hole, variable expansion cosmology. It's much better than the Big Bang. And we'll look at Humphrey's white hole cosmology. It has a very interesting timeless zone in it. That sounds enigmatic. That's why we'll look at it. And the theory starts with water. The universe that is water. Then we'll talk about Jason Lyle's and isotropy synchrony convention. I'm sure that means a lot to everybody right now. Okay. All right. Let's go forward. A lot rotates around this word, the Hebrew word for day, which is yom. It commonly is pronounced that word. I've heard some experts say, no, it's pronounced yom. I'm not sure, so I'll just go with the flow. Say yom, that's what I'm in the habit of. All right, it has several meanings or usages. Be the daylight portion of a day from dawn to dusk. Okay. Could be the daily cycle, including one period of daylight, one period of dark, of nighttime dark. It could mean an infinite period of time, an indefinite period of time. As in the phrase, in the days of our fathers, or in the day, many usages like that. Some like to go through and make that list and go through, and every time they run into the word in Genesis or somewhere else, they go down and listen, well, which one do I like to use here? Because when you do that, that's not exegesis, that's eisegesis. You're reading your own thinking into that, your own preferences into God's word. You're, in effect, placing yourself in the place of God. That's a no-no. It's not exegesis. If we want to do exegesis, we need to look at the rest of the Bible and see how it uses that word for a given context. You have to look and study the context in order to understand what is meant by a word in that context. If you don't do that, you're probably just reading your own thoughts into it. Okay? You need to search out the consistency in what God tells us and the way he uses language. All right. Yom occurs 2,291 times in the Old Testament. So that's a lot. In nearly all cases, the context clearly means an ordinary solar day. Therefore, it's the primary meaning of that word. And if you don't give it that meaning, then you need to have a specific reason, not just well, I'll choose this. I like that. Okay. The plural form of yom occurs 845 times, and it's always in the context of an ordinary day. Uh, if you don't use that meaning when it's the plural form, then you need to have a good reason for that. Okay? Yom is modified by a number 350 times in the Old Testament. That is day 1, day 2, or 500 days, or X number of days. When it's enumerated, then it means an ordinary day is 359 times. Now, I know one gentleman that says, oh, there's one exception to that. And he says that one exception he interprets as meaning an extended period of time. And he concludes from that, then he can always use yom as an extended period of time. Okay? Now, wait, this is a little bit crazy. He's throwing out the 358 and taking the one as the predominant thing. It makes no sense to me. If you have 358 and 1, then you need to go with the predominant number. Okay? In other words, you need to go with the 99.7% probability that you're making the right choice with the majority. Okay? So, if yom is modified by a number, it's always an ordinary day. Okay. When yom is modified by morning or evening throughout the Old Testament, it is always in a context that indicates an ordinary day. So here we have 4 things that contextually point to the meaning of an ordinary day. When you see these kinds of 4 markers, okay? In the 6 days of creation, there's a pattern. Each day begins, and God said. Each is associated with 1 morning and 1 evening. Notice it's singular. And each is numbered. Okay, so you have the morning and the evening and the numbering. In each case, both of those mean that it is a ordinary day. And the fact that the morning and evening being singular, again, reinforces that. Here's an example of that pattern. Verse 3 says, then God said, and whatever action there was. So the evening and the morning were the first day. Of course, the order evening and then morning is normally Hebrew. The day begins at sundown for the Jews. Okay, the Sabbath starts at sundown. And so that may seem a little awkward to us. That's just a culture. Okay, so this gives a triple identification with an ordinary day. And that reoccurs with each of the 6 days. Okay. Okay. Throughout creation acts, the acts include the supernatural. They are not limited to the physics we observe today. So we need to have an open mind to that. The sustaining of nature now is what we call the laws of physics or other laws of science. But what we find in the creation narrative, there will be many things that cannot tie with that We need to be open to God's supernatural creative power. Okay? And because of that, we cannot extrapolate what we observe today back into creation. Because as soon as you start, when you try to extrapolate back in time, and you run in one of God's supernatural creative acts, it doesn't follow those same laws, then if you try to extrapolate back beyond that, then you will have a falsehood that you're just making up. That makes sense? Okay. All right. Here's another biblical text that sheds some additional light on God's intended use of the word day. It's in his fourth commandment in Exodus 28 through 11, which reads, "Remember the Sabbath day, keep it holy. 6 days you shall labor and do all your work. But the seventh day is a Sabbath of the Lord your God. In it you shall not do any work, you or your son or your daughter, your male or female servant, your cattle or your sojourner who stays with you. For in 6 days the Lord made the heavens and the earth, the sea and all that is in them, and rested on the seventh day. Therefore the Lord blessed the Sabbath day and made it holy." All right. So he's using the same word for day to mean to compare with the days of the work week. There's no doubt about that. That in each case they're all using the same word to refer to each one of them. The 6 days of creation, Sabbath day, the work days, and so on. This all means same word, and it's an actual day. It's not an extended period of time. Okay. When Yom does not meet the above criteria, it can mean a long period of time. No doubt about that. The first occurrence of this kind of context is in Genesis 2:4. This is the account of the heavens and earth when they were created, in the day that the Lord made earth and heaven. Here Yom, or day, it's not numbered. It's not associated morning or evening. Here day refers back to all of the days of creation. So the context is consistent with a longer period of time than 1 day. And it doesn't bear any of the markers we spoke of earlier as indicating an ordinary solar day. Okay. And one of the funny things is that some of the old Earth brothers of ours try to point to this verse, and this uses it and say, see, Yom can mean extended period of time, number of days. Therefore, you could use Yom in all the days of creation to be an extended period of time. No, we just showed you why that's not true. The context clearly marks what the meaning is. Okay. There's a couple other words that often presented as being significant in this kind of reading. One is bara, the shape, to shape or create. Only God can do this. It's only used when God is doing something. Okay. And there's asa, to do or make, not create, but to do or make something, some action. Both God and man can do this in some sense. If you go through Genesis 1 and the first part of chapter 2, look at all the instances. Sometimes God is said to both bara and asa. Sometimes just bara. Okay. So you can't say that one of these words always means just one thing and the other one always means the other. But bara means something that only God can do. Okay? But you can't look at any time asa comes up and say, oh, that's an extended period of time or something, or that's an extended action over. That logic really does not follow. So there are people who try to push that logic. Okay. Creation is a supernatural action throughout Genesis. In general, each act of creation includes a lot of supernatural activity. This includes both creation of something out of something new out of nothing. It also includes forming or shaping material that already exists into something new. Okay? Throughout the creation, acts are supernatural. They are not limited by the physics we observe, and he sustains now. Therefore, we cannot extrapolate the present physics back in time to discover how God created things. He didn't use the present physics. He may have used some of it, but some of it may not have been in place at the time he did a given creation. We might be successful in taking God's word and extrapolating from that into better understanding of the presently observed science. There's still a lot of mysteries in science, a lot of things that nobody really understands. It is possible that studying the creative mechanisms might give us some hints about how some of these mysteries work. So that's always a worthwhile attitude. We might run into a couple of examples later. Okay, let's do a little review of the creation narrative just to bring it back to mind. In Genesis 1 through 5, we have that famous preamble. It says, in the beginning, God created the heavens and the earth. And that's often taken to be a separate sentence that is a summary of all that follows. Then it goes on. Before the first day of creation, the earth was formless and void, and darkness was over the surface of the deep. And the Spirit of God was moving over the surface of the waters. Then it goes on with the first day. Then God said, let there be light. And there was light. God saw that the light was good, and God separated the light from the darkness. God called the light day, the darkness he called night. So right here on the first day, he created light, and he defined what it is. And he created the absence of light and gave that a name. And then he says, and it says, and there was evening, and there was morning, one day. So it has all of the markers of, it has several of the markers of using the day yom to mean an ordinary solar day. And 1 through 8, Then God said, let there be an expanse in the midst of the waters. Expanse. Okay. We'll study that some more. And let it separate the waters from the waters. God made the expanse and separated the waters which were below the expanse from the waters which were above the expanse. And it was so. God called the expanse heaven. And there was evening, and there was morning, a second day. Yeah, all those markers of a single day. Day with one morning, one period of light, one period of dark, one morning, one evening, one day. Okay, and it goes on. Then God said, let the waters below the heavens be gathered into one place, and let the dry land appear. And it was so. God called the dry land earth, and the gatherings of the water he called seas. God saw that it was good. And it goes on. Then God said, let the earth sprout vegetation, plants yielding seeds, and the fruit trees on the earth, bearing the fruit after their kind with seeds in them. And it was so. The earth brought forth vegetation, plants yielding seed after their kind, and trees bearing fruit with seeds in them after their kind. And God saw that it was good. There was evening, and there was morning, a third day. So all of this from 1:9 through 13 is day 3. God had 2 pronouncements in that day, but it's still all day 3. Okay, 14 through 19. Then God said, let there be lights in the expanse of the heavens to separate the day from the night. Okay, I've got something confused in my mind. And let them be for signs and seasons, and for days and years. And let them be for lights in the expanses of the heavens to give light on the earth. And it was so. God made the 2 great lights, the greater light to govern the day, and the lesser light to govern the night. And he made these stars also. So God placed them in the expanse. That'll be significant later on. And the heaven of the heavens to give light on the earth, and to govern the day and the night, and to separate the light from the darkness. And God saw that it was good. There was evening, and there was morning, a 4th day. Okay. You might mark a note in your mind that God placed the stars in sun, moon, and stars, actually. He placed them in the expanse of the heavens. Whatever the expanse of it, he placed them inside the expanse. All right, now let's go ahead. Then God said, let the waters teem with swarms of living creatures, and let the birds fly above the earth in the open expanse of the heavens. God created great sea monsters and every living creature that moves, with which the waters swarmed after their kind, and every winged bird after its kind. And God saw that it was good. God blessed them, saying, be fruitful and multiply, and fill the waters in the seas, and let birds multiply on the earth. There was evening, and there was morning, a 5th day. Okay. It has birds above. Let birds fly above the earth in the open expanse of the heavens. Many translations say on the surface of the expanse or on the face of the expanse. How to mark that in your mind? It would be significant. Or the birds flies on the surface or the face of, or the open face of the expanse, or the stars and the sun and the moon is inside the expanse. Should give you some hints about what that expanse is. Okay. Then God said, let the earth bring forth living creatures after their kind, cattle and creeping things, and beasts of the earth after their kind. And it was so. God made the beasts of the earth after their kind, and cattle after their kind, and everything that creeps on the ground after its kind. And God saw that it was good. Then God said, let us make man in our image, according to our likeness, and let them rule over the fish of the sea, and over the birds of the sky, and over the cattle, and over all the earth, and over every creeping thing that creeps on the earth. God created man in his own image. In the image of God he created him. Male and female he created them. God blessed them. God said to them, be fruitful and multiply, and fill the earth and subdue it, and rule over the fish of the sea, and over the birds of the sky, and over every living thing that moves on the earth. Then God said, behold, I have given you every plant yielding seed that is on the surface of the earth, and every tree which has fruit yielding seed. It shall be food for you. And to every beast of the earth, and to every bird in the sky, and to everything that moves on the earth, which has life, I have given every green plant for food. And it was so. God saw all that he had made, and behold, it was very good. And there was evening, and there was morning, the sixth day. So that should be very familiar to everybody, but we'll recall some details there. So let's, with that in mind, let's take a look at Dr. Danny Faulkner. Faulkner is a retired professor of astronomy at the University of South Carolina. Now in retirement, he's at Answers in Genesis, and he's also a member of the Creation Research Society board. He's very definitely a long time and well-known young Earth creations, even at the university. He's one of the few that has gotten away with that in a secular institution. But he earns that high respect that enables that. Okay, what he has proposed in 2013 was a theory he calls the Dasha theory. It's a new approach to the starlight time problem. I'm not so sure about the new, but it is one of them that needs to be discussed. Okay. Faulkner claims that light arriving on the Earth in time for Adam to see it from stars that are now billions of light years away, or millions, hundreds of millions, or billions, was simply a supernatural act of God. It was part of the creation scenario, and God got the light here fast. It was actually emitted by those bodies, and God got it here fast because that's what He needed to happen. He doesn't try to explain how that is. He says that's supernatural. And he's an astronomer, been thinking about this for 30 years. And he's aware of a number of other theories that other PhD level people have presented. And this is the conclusion that he has come to. And he still maintains that today. So it's lasted at least a little while. And he says he's real comfortable with it. The Hebrew, he draws some support from this from Genesis 11 and 12. Then God said, let the earth sprout vegetation, plants yielding seed, and fruit trees, and the earth bearing fruit after their kind, with seeds in them. And it was so. The earth brought forth vegetation, plants yielding seed after their kind, and trees bearing fruit with seeds in them after their kind. The Hebrew word sprout in that passage is dasha, which means to sprout, to shoot, or to grow green. So, of course, they did all of that in one day. You had sprouting, the shoots growing up and growing to green plants all in one day or 2 days, because you had to have that for all the animals that got created on day 6. So this is an example of how God makes things mature very rapidly to fulfill His creation needs. So that makes a lot of sense as far as that goes. But can you, it makes some sense to apply that to the starlight and time problem too. He created the stars. If Adam needed to see that for them to fulfill their function of time and seasons and days and so on, then somehow it had to get here. And as far as Faulkner is concerned, well, it's just part of the supernatural acts of creation. Some others want to see more than that. So. Okay. Jump ahead a little bit. He later speculates that we are seeing the whole universe in near real time, even now. That is the most satisfying thing he has found after 30 years as a professional in astronomy, doing and publishing research, teaching in a university. So someday it would be real interesting to Faulkner to explain that more thoroughly. That's where he is right now. So let's look at some of the proposed cosmologies Faulkner has considered all this time and see what they have to say and what's good about them and what's falls short. Okay, let's stop for a moment. Permit some quick questions about Faulkner. No? Okay, one, Jay? Mm-hmm. You don't understand how that works. Neither does he. And he admits to that. So he doesn't see any of these other theories as to being complete and clear and without problem. So he reverts to this. he takes that as an indication that, well, this is just supernatural. Yeah, we'll see a couple of theories that will tell us some things about that. Gene was first.
Actually, one way you can look at it, probably good influence. God created me to have to change the course, cut off the first kind of course, but take it from, and so this is to help you to see life. You definitely is to see life real fast. There's four. The wavelength is small. The wavelength is too light. The light is
Okay, let me try to.
so we have to do with the fast, and then it goes down. The wavelength goes, everything's already here.
Mm-hmm. Okay, just we want to make these question answers. My computer's trying to help me out. I want to make this a little bit briefer. Let me summarize what Gene said, that God can manipulate through creation processes. God can manipulate the speed of light just the same as he can with anything else. He can control it, make it faster or less. Okay, Gene's a retired NASA physicist. Dr. Grissom?
This could not be explained by the electron probe on the space line. Only is going to
Okay.
talk about that stuff. But there's a passage where John says that word change goes is going to be like just after heaven. So, the space that he north may have been looking forth back there, and then they say that is already there.
Okay. So Dr. Grissom is pointing out that Tony Como will be speaking next month on the work of Menachem Simhoni, professor of physics in Israel. And he has a definition of space, how it is physically composed. And that is at the root of just about everything we're going to talk about today. And it's the one thing that just about all these theories fall short on. So that is going to be an extremely important thing to come see and hear. It will be fascinating. He might answer some of the questions we can answer tonight. Okay, let's move on real quick, Virginia. Excuse me? Near real time means that the light gets from the stars to here almost instantaneous. Now that's a real mind twister. Okay, we need to go on right now, and we're going to see things about all of these things later on. Okay. 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 All right. Let's talk about the Big Bang Theory a little bit. This is the gold standard for all the secular scientists and people, so far as they're allowed to talk about anyway. The one characteristic is that it keeps God pretty well out of the picture. And yet, there are a lot of creationists that think this is hot stuff. So we need to be up to speed on this. Okay, Big Bang is based on Einstein's general theory of relativity, which within anything that we can measure with high precision, it is at least that good. Almost. You might debate some real fine points. But when you get out to galaxies or something like that, it's tough to measure some of those things. So it might be some things to talk about there. Very, very briefly, the theory might be stated as everything starts with a quantum fluctuation, producing all the matter and energy in the universe at one extremely hot point in space. It expands outward in space-time and cools as it does, forming nuclear particles, then atomic nuclei and plasma, then neutral hydrogen and helium gas atoms. With further expansion and cooling, the gas clouds contract and clump into clumps that are eventually formed into stars and galaxies and clusters of galaxies. Along the way, stars burn up their fuel and explode, producing more heavy elements than hydrogen and helium. Eventually, that stardust produces planets like ours, with people studying all they can see. That's, in a nutshell, the Big Bang Theory. And you see, it's kind of a creation story. It's an origin story. Okay. In the corner there, we have an illustration that is a NASA illustration that illustrates all the things in the theory. On the left you have this bright spot, and there's a quantum fluctuation, and then there's a period called inflation. We'll talk about that some. And then eventually, after there's just dark gas, then you start forming stars and galaxies and so on. And it's expanding, and then starts later on expanding even faster. So that's really a pretty good illustration. When we're told all this without critical questioning of it, it sounds pretty good. It can be made to sound pretty good to somebody that is not well informed about the problems involved. And it fools a lot of people. One of the actual facts is that one of the assumptions inserted into Big Bang Theory and Big Bang cosmology is designed specifically to keep God out of the picture. It's called the cosmological principle. And it says that there is no special place in the universe. There's actually no center nor edge of the universe. Now, that doesn't make much sense in 3 dimensions, but actually it can make sense in 4 dimensions of general theory of relativity. But they hide behind that, and they have no particular evidence for it. It's an assumption. It's an assumption. And it's there in a direct contradiction of the Bible saying that everything was built around the earth. We'll see that some more later on. Okay, some problems with the Big Bang. That's what we want to talk about. About that quantum fluctuation. It should produce equal amounts of matter and antimatter. And the conservation of energy, which is the most fundamental law in physics, requires that. But in fact, in the universe, we can't see any antimatter, except possibly very short periods of time under some extreme situations. We can produce antimatter in particle accelerators in laboratories. They exist only for very brief periods of time, and it annihilates with other things. So it's a huge, huge mystery. Why is there not great clumps of antimatter somewhere? Why are there not galaxies made up of antimatter? Okay. Also, the theory, those kinds of events should produce something called a magnetic monopole. You have a bar magnet, it's got a north and a south pole. Well, theoretically, there can exist those poles independent of each other. But none have ever been observed under any circumstance. David?
40 to 50 years ago, there was a physicist named Brock. He invented a device called the superconducting quantum interference device, and he observed one event that indicates that a magnetic monopole has occurred.
Okay, but you can't.
The signal was exactly the right size and everything. To be a magnetic monopole that never been observed since.
Okay. What David's saying that people listening through the microphone can't hear is that one guy one time had recorded an event that looked like a magnetic monopole in every physical way, but it's a one-time thing. Nobody. So you can't do science with a sample of one.
That's true.
You can't.
Exactly right.
It can raise a lot of intriguing questions, but well, there should be, according to this kind of event in the Big Bang theory, there should be lots of magnetic monopoles all over the place. They're not there. Okay. Also, we have the cosmic background radiation. There should be substantial temperature variations in that cosmic background radiation. But in fact, what is measured is that it's the same temperature within 0.001% of the average temperature. It's extremely little variation anywhere. And it's a radical departure from what should be expected. Now, there is a problem here also, because to get everything to the same temperature, you have to have heat flowing or energy from one kind or another flowing from one place to other places. Where there's a hot spot, it needs to flow out to where there are cool spots, and all leads out, comes to thermal equilibrium. All right, then you can have very, very uniform temperatures. But there are parts of the universe that are so far apart that the light from one part cannot travel to the other part in the age of the universe. That's a light travel type problem for the Big Bang. So because of that, you cannot explain this away. You might get this out of something that was just supernaturally created, but not from explosion event type of thing. Okay, well, the Big Bangers have conjured up an answer for these. These three things be fatal flaws for the theory. They conjure up a way out that at least they can convince themselves is a way out. It's called an inflation event. And if we go back to this diagram here, we have this end where it gets very large very fast. And actually, this is a nonlinear time scale here. This is expanded so that you can see, because it gets large by something like a factor of 10 to the 15th time larger, and it does that in like a trillionth of a second. So really, they ought to put this on a linear time scale in which the end of that thing would be perfectly flat. Okay. So inflation, what inflation is supposed to do is it's supposed to smooth everything out. Now, so there's a little problem with inflation. Nobody knows how it got started. Nobody knows what drove it along. And nobody knows what stopped it once it got going. There are not clear physical mechanisms for this. There are something to talk about, and there are a number of different variations on how they talk about that. And the 4 illustrations here were published in New Scientist, I believe it was, to illustrate some of the different thinking about this. But there's not a clear picture of physical cause and effect for inflation. And yet they regard this to be good enough to cover up those 3 fatal flaws. Okay. Science? David?
In almost 14 billion years, why has there never been another big bang?
I can't answer that. Yeah, but they didn't come from. Okay. Now, when it comes to the gases cool off and contract, and cools off and contracts, eventually you get to a point where gas clouds should break up into clumps and contract and form stars. Only there's a basic problem there too. When you compress a gas, it gets hotter. And then if it gets hotter, it means the pressure goes up and it expands back. Okay. So when you go through this process, it can be shown that there is a what's called a Jeans limit, referring to a famous physicist, that it tells us how far this contraction can take place under the force of gravity before the gas pushes back so much that it can't compress anymore by gravity. So this is a big problem, and they've spent a lot of time trying to figure out, well, what could overcome this? What could get past the Jeans limit? The Jeans limit is pretty low density gas. It's not much contraction there. Well, if you could have some dust in the cloud, then that would help radiate more light energy away, and that would help cool it. But wait, there's a problem here. Dust comes from supernovas, which is exploding stars. So you got to have stars before you can have dust, and so this won't work for the first stars. Okay. You could also have a newborn nova and have a pressure wave go through the cloud, and that would help nucleate some further contraction, maybe. But again, you got to have a star to explode first. So you got a chicken and egg problem here. You don't know how to get around that. You could also have an extra source of gravity, such as something they call dark matter, but we'll talk about that later. They can't detect any dark matter, I'll tell you right now. Okay. All right. In this illustration in the bottom here, we have a depiction of how stars are supposed to form in the solar system. You have a gas cloud, and it's supposed to contract and contract, and eventually, if it has any, if it's rotating any at all in the beginning, the more it contracts, the faster it rotates. So when it starts contracting into a body, it'll form a disc like this. And if this thing really gets hot like a star does, then it'll start blowing it some energy out the end perpendicular along the axis of rotation. Supposedly, it's supposed to start breaking up. The disk starts supposed to be breaking up, and then it forms planets like that. Well, there's a strange problem. This process predicts angular momentum. If it had to be a good bit of angular momentum there for it to do this at all. And it predicts the angular momentum is 99.7% in the star. That's believable. Most of the mass is in the star. So. But in fact, our solar system, at least, only 2% is in the star. The rest of it's in the planet. So they got this prediction just absolutely backwards. Okay. This kind of scenario just predicts the wrong thing. Besides all of that, the first stars will only have hydrogen and helium in them. We've never observed a star that has only hydrogen and helium in it. It's called a population-free star. And no matter how far out in the universe you can see 13 billion light years out. No population-free stars. There should be galaxies that are dominated by population-free stars as far. But we keep seeing the same kind of galaxies we see now. So it doesn't match with this. Okay. Obviously, stars and galaxies did form, though. We'll have to give them that much. But it wasn't the Big Bang way, as we just saw. In the galaxies that we observe, the stars and the galaxies orbit around the galaxy. Okay. And they orbit faster than general relativity predicts. Okay. The error increases as you go out from the galaxy, and that's what this illustration about. This is a galaxy, and it gets, it's actually a spiral galaxy, but it's kind of underexposed. The spiral arms, then you're out here, and there's gas and dust that go far out, farther than and it's all orbiting that galaxy. The prediction of general relativity and Newtonian physics, it's at these speeds, it's all the same, is along this line. This is what's expected from general theory of relativity. This is what is actually observed. These are actual measurement points for this particular galaxy. And they have done this with thousands of them. And this is a universal problem. They all have this kind of problem. Notice out here that this is roughly 200% error. This is not little bitty small errors. This is a fatal flaw type error. It says that at galactic distances, you have the same things going on with clusters of galaxies. So the galaxies orbit around each other in their common center of gravity. And clusters of galaxies, superclusters. They all have this kind of problem. General relativity cannot deal with it. They need something better, some improvement in general relativity. So they dreamed up something. and they call it dark matter. Okay, they have something to supply more gravity in this system. You might be able to get something like that, but it has to be in a particular form. It can't be just anywhere. It has to be a sphere of mass that is much bigger than that galaxy, and it's spherical in shape and distribution. It's not just some random thing. Not any old thing will do. But they can't detect anything like that, so they call it dark matter. Okay, so let's talk about dark matter. Dark matter is proposed to answer many problems, and it just has to be there. They have done a lot of experimental work on this. There have been international teams of scientists doing high-level, very expensive super collider type experiments and stuff, trying to define what dark matter might be. And they take this information, then they try to do experiments to measure dark matter in the universe, anywhere in the universe. So I said these galaxies, we're just looking at things like that. And what they find is that they have gotten more and more and more precise, and now they can measure that the value is 0, many decimal points. So they either dark matter, if it exists, is something entirely different from anything they think of, have any physical basis for it, or it's simply not there. And I would bet on, and things we'll see later, I would bet on the latter. It's not there, it's not even needed. A modification of general relativity is much needed. Okay, there's also another problem. You remember back in the 1990s, universe was discovered not only to be expanding, but to be accelerating in the expansion. Faster and faster and faster. Not real fast acceleration, but it is getting faster in the acceleration. And the only thing that could cause this would be more energy just throughout the universe. But what kind of energy? Nobody knows. Nobody knows how to look for it. So they call it dark energy. You can't observe dark matter or dark energy, but it's got to be there. Okay. For the Big Bang to work, the universe must be comprised of 74% dark energy, 22% dark matter, 3.6% intergalactic gas. Most of that's hydrogen, of course. And 0.4% of it is the ordinary visible matter in stars and galaxies that we can observe. So 96% of the Big Bang universe is invisible, undetectable, and undefined.
Without this energy, nothing would happen.
Right.
Everything you're explaining requires incredible amounts of
Yes.
compressed gas.
Yes.
And it has to be controlled energy. It's not something that's just
You're right. We'll talk about some attempts to get a better theory. Okay. All right. The attempt to extrapolate the present back in time to an origin without God just doesn't work. That's what the Big Bang theory is all about. It doesn't work. Okay? But secular science, they just can't talk about God. So any quick questions about Big Bang? We're running over time, so I better get on, and we better skip that and do questions later, okay? All right. Okay. I forgot I did this slide this way. Okay. There's a professor, Dr. Edward Larson. He's a professor of law and history. Back in 1999, he did a survey of the scientific community to find out what the scientists believe. Because there was often a lot of controversy about what might be appropriate in various policy making things. So the big question he asked is, do you believe in a God that answers prayer, in an afterlife, and the God-guided evolution in some manner? Now you need to recall that the biology teaches that evolution is entirely random and purposeless and uncaused. It's just random. Okay? So believing that God had it is a real affront to the scientific community. So the results he got from a broad scope of scientists, he took a scientific random sample from a who's who type book that is for the scientific community of all the professional scientists. It's not people in school and so on. It's a professional. He found that 40% agreed with these three statements, and the 16 did not. Well, the 60 is a majority, but surprising, 40% agreeing with this strongly theistic Judeo-Christian is surprisingly much to me and to a lot of people. A lot of scientists in their private life have some strong theistic beliefs. That's good. Now, he also surveyed the National Academy of Sciences. Now, this is a body way back many years set up by Congress to advise Congress and their independent body, and they elect their own membership. That's kind of a key thing, because they're not going to elect people that are not like-minded. So it tends to be get stuck on certain kinds of ideas. National Academy of Science, only 7% would agree with these three statements, and 93% do not. These are guys in control of the scientific community. They control the funding of projects. You want funding, you better not take them off. If you want to publish, it's publish or perish, but if you want to publish, you better not take these guys off. They do the peer reviewing anyway. If you want a career advancement, you better not take these guys off, because they're the ones at the top of all institutions. Okay, so that's kind of why you can have Big Bang type theories and nobody's making too many waves. Probably so, yeah. Okay, so having that picture in mind, let's look at some creation cosmology. Okay. All right, I better step on it here. Not on the website, no. I plan to make a paper out of it. That's right. It will be on DVD, at least, if nothing else. Okay, we're going to look at the Carmeli-Hartnett white-hole origin model and the Humphreys white-hole origin model. It's different, quite different. And then Lyell's infinite speed of light model. All these gentlemen have PhDs in physics or astrophysics. All are younger creationists, have been for a long time. Okay? All had long accomplished careers in secular institutions, with the exception of Lyell. He's a fairly young fellow. Okay, but a PhD astrophysicist nonetheless. Okay, let's talk about Masha Carmeli. He was Albert Einstein Professor of Theoretical Physics at Ben Gurion University in Israel. As such, he was a specialist in general theory of relativity. He published a textbook on general theory of relativity. So he's pretty much a world-class expert in relativity theory. Okay. In the early 90s, Carmeli took up a project of developing an improved cosmology, a better theory than the Big Bang. Okay. He had just retired and could then do what he wanted to. This is what he wanted to do. Carmeli is not a creationist in the sense that we talk about. He is Jewish in background, of course, and probably in some kind of nominal sense creationist. But his goal was not to generate a creationist theory, simply a better theory. Okay. And Carmeli named his theory cosmological relativity, or cosmological general relativity. Okay. He starts with Einstein's general relativity theory and he adds a fifth dimension to Einstein's theory. It's already a four dimension, that's hard to deal with. He called the fifth dimension space velocity, and it represents the rate at which space expands at every point in space. Could be different. Okay. Previous things like Big Bang assume that it's all according to it's expanding at the same rate everywhere. Okay. And that accumulates over distance, of course. So he throws out the cosmological principle immediately when he does this, or he doesn't assume it. If you set this extra dimension to zero, you get back to general relativity. But so he's talking about the expansion of space is some kind of fundamental property of space itself, but it's variable everywhere. Okay. By 1996, Carmeli derived from his starting assumption. Didn't extrapolate back in the past. He derived from starting assumptions a three-phase universe history. Early rapid expansion, middle coasting phase, and following by accelerated expansion, which we should see today. And he published this. It was yet unobserved in 1996. But in the late 90s, scientists were trying to learn more about the universe as a whole, and they were looking at the expansion of the universe, and they were expecting to see that it was slowing down. Carmeli is predicting it would go faster, accelerate. And they discovered that it was accelerating. And this dumbfounded them. But Carmeli was expecting it. Okay. In 1998, the accelerating expansion of the universe was discovered. And other astronomers published data seemed very perplexing at times. So this was a great success. Unfortunately, Carmeli died in 2007. Before he did, he published the book on the left, Cosmological Relativity. That's my own copy. I love that picture of Einstein on that, with one raised eyebrow looking askance. Oh, yeah? You're reformulating out there. Must not. In the last couple of years before Carmeli died, he was editing a lot of a number of articles compiled into a book. and it's a 500-page book. And this is a description of mathematical theory. It's not a picture book. A physicist in Australia named John Hartnett took up that and completed the book and got it published. And he had already started collaborating with Carmelli. They had visited each other several times. And Hartnett was going along. Here's some things that Hartnett came up with. Okay, did not prove that he demonstrated the theory does not require homogeneity. That is basically the same thing as saying that the cosmological principle, it doesn't have to observe that. It can account for other situations as well. And checks theory against many different forms of data, and showed the degrees to a lot of different kinds of astronomical observations. He shows no need for dark matter and spiral galaxy rotation curves. It predicts the correct rotation curve. Carmelli's theory predicts this one, not this one. So in this way, at least it is better than general theory of relativity. Okay. All right. It also same thing for clusters of galaxies and super clusters. Okay. What about creation events? In the beginning, God created. How does all the theory fit with Genesis? All right. Carmelli was thinking about better Big Bang, not creation science. But Hartnett was saying, why is he thinking about creation? Hartnett shows that very early there must be a short period of very rapid expansion of the universe. That kind of sounds like inflation, doesn't it? Which quickly settles to a constant normal rate of expansion. Okay, but that's what came out of it. During the very rapid expansion, Earth time at the center would be very much slowed or dilated compared to the time far out in the universe. During the constant expansion, there would be no time dilation. Time then runs at the same rate on Earth at the center and far out in the cosmos. He proposed that the rapid accelerated expansion took place on the fourth day of creation. So it kind of meshes there, at least to that extent. And we find this illustration in one of his books. Over here, we have a galaxy in the center and a bunch of others around, and they're all expanding out at a fast rate. On Earth, somewhere in this galaxy, time would be going very much slower than time out here in the cosmos somewhere. Okay, now after that fast acceleration on Earth, and everything has gone through a bunch of expansion, you see, then the time rate on Earth and out there in the galaxies is the same. Now, this is calculated. It's not just picture. So during rapid acceleration expansion, light always travels at the speed of light, but will get to Earth in a very short time by Earth clocks. after the expansion becomes constant, at today's rate, light travels from 1 billion light years at the speed of light and gets here in 1 billion years. It's measured by Earth clock. I think that should say as measured by Earth clocks or by the galaxy clock, galactic clock. Okay, check that out. Hartnett is developing an approximation of time by Earth clocks light would require to travel from a cosmic distance, galaxies away, to the Earth, or at least far stretches of this galaxy. Now this is an approximation. This is a hypothetical type of thing. In fact, he took an approximation of a step function. But he shows that light can get here very quickly, about as quickly as you want it to if you design that function right. Okay, and that you can design functions that fit into that theory, and it all computes. It all works together. That in itself is a big step. So here is a graph. I took one of his equations and graphed it here to see what the results is. On the horizontal axis here, we have the distance out to a star source somewhere. So this is radius out, and this is in light years. Okay, so it's 10 light years, 1 light year, and so on. We have the days of creation up here on the vertical axis. And we have the distance versus the days of accretion here. So that any, if you had this model here, this dash dot black line, and anything from 10, 1, or all these great distances out here, this would include all the nearby stars and so on, it would get to Earth in 1 day after admission. For the blue line model, it would be 3 1/3 days, something like that. Okay, the red line model, it would be 10 days. So it shows that it is possible to have physical situations within that model that can get that light here as quickly as you need it. So that's really interesting. It doesn't produce a definitive result, but it says that this theory can work with those types of events. Okay. So quick conclusions about cosmological general relativity. There's strong reasons to reject the Big Bang. I'm getting tongue-tied. The big problem is the homogeneity thing, the cosmological principle, and that's all there just to avoid God. To avoid people asking, well, is that a place for God? Is that a center of creation or something? Primarily in Hartnett's cosmological relativity. Correctly predicted acceleration of the universal expansion. It drives something called a Tully-Fisher relationship, which was an empirical thing. They knew it was true, but they didn't know why it was. Primarily gave them a model, a mathematical model of it. That's why. It eliminates the need for dark matter or dark energy. Has many fewer free variables than Big Bang theory has in it. That's a good thing scientifically. It provides a natural environment for observing concentric structures, like things around a center of expansion, which Big Bang denies. Allows star height quick arrival from a distant galaxy. Potentially provides a model that emerges out of God's supernatural creative acts of Genesis. So cosmological relativity is scientifically a superior theory to Big Bang. And cosmological relativity is also a biblically superior theory. Okay, so this should be very encouraging. It's not definitive. It is not taking over the scientific community because, well, you tell me. But that's right, not invented here. Okay, so let's go ahead, and it's getting kind of late, so let's go ahead with Dr. Russell Humphreys real quick here. This is maybe more interesting. Humphreys has a long career in physics, very successful. Most of his career is at Sandia National Labs, which is one of the major national laboratories. Very, very sophisticated stuff going on there. He's long been a younger creationist. Humphreys started with general relativity, but Einstein's equations have many possible solutions. They're so complex that you have to start to do anything with them. You have to interject some simplifying assumptions of some kind, and then you start producing solutions. So there are many ways to do that. So Humphrey went through that process in a different way and came up with again, excluded the cosmological principle. Humphreys developed a solution to Einstein's general theory of relativity equations that are different from what is commonly used. That's what I was trying to get around to. Okay, let's start with space and talking about this. Recognize that space is not empty. Both science and scripture strongly imply that space is a solid material that we cannot see or feel. We move freely through it, and it moves freely through us. I'm quoting Humphreys here, or paraphrasing Humphreys. In points to Isaiah 40:22, God stretches out the heavens like a tent curtain. This and 16 other similar verses invite us to compare the material of space to a stretchable fabric under tension. A good example is a trampoline, something we're familiar with. So he has a trampoline illustration that sometimes might be a little bit confusing. The vertical dimension of the trampoline here, this trampoline illustration, the vertical dimension of that represents the way the space-time continuum can be bent. The presence of mass bends the fabric of space. So that's what it's an analogy to. The depth of the dent at any given point is proportional to the gravitational energy. The slope of the fabric is proportional to the gravitational force. Okay. Recall in Genesis 1:3, in the beginning God created heavens and earth. The earth was formless and void, and darkness filled the surface of the deep. And the Spirit of God was moving over the surface of the water. So deep pretty well makes you think of deep water, especially since water is mentioned as being on the surface. So Humphreys hypothesized in his theory that God started with a ball of water and created water first, and then created all the other materials from the electrons and protons and neutrons that was in the water, the oxygen molecules and the hydrogen molecules. If you to have enough water and all the other actions that follow, you would have to have a bottle of water that's a few light years in diameter. I've illustrated that over here. You may not believe that's a few light years, but there it is. Humphrey's trampoline model is over here. So you have, I don't like this, that ball should be smaller compared to the trampoline. It would be better, but here is a ball of mass depressing the fabric on a trampoline. Okay. Up here we have my illustration of a ball of water, the deep, and that's where we're starting this slide. Beginning with the second day of creation, we have 6 through 8. Then God said, let there be an expanse in the middle of the waters, and let it separate the waters from the waters. God made the expanse and separated the waters which were below the expanse from the waters which were above the expanse. And it was so. So at the center of the deep, God marked, this is paraphrasing Humphreys again. At the center of the deep, God marked off a relatively small spherical region of water. And he marked it off with a thin region of space, empty to our perception, but really a material, that he called the firmament, or in other translations, the expanse. The Hebrew word that is being translated there is rakia, and it suggests something that is solid, that was spread out. Okay. So after the separation, Humphreys is saying they marked off a little bit in there and then put that firmament in there and expanded it out rapidly. And after that entire process, you have Earth's a little dot in here so small you can't see. This is about 24 billion light years now. And these are the waters above. These are the galaxies and stars he created, and Earth in the middle. In terms of the trampoline model, if you take a cross section of this, then you have an annular ring. You have, this should be a little bitty dot, okay? So this is sloping down. This is almost flat in there in the annular ring. So we'll look at some graphs of this in a minute that help clarify that some more. So let's consider this graph of the trampoline analogy. Suppose the water is above. I'm going to abbreviate that WA. Vertical axis is gravitational potential. This peak is gravitational potential. The horizontal axis is radius from the teeny Earth at the center. The radius of the waters above is shown in billions of light years, okay? So this is a huge distance. Now, note that there is a critical value of gravitational potential below which time stops. So if any of this model extends below the critical potential, then you have everything that's in that little section there. Time is stopped. It's not flowing. It's actually imaginary, which is kind of like saying the same thing. It doesn't exist in that region. So there's two things that affect how much is in there. How much is this slope? If and how much tension is being applied to that trampoline, pulling it out. If you pull it out at the edges, then all of this will rise up. Then God could alter the conditions to control what this critical potential is. So there's a lot to manipulate things. Okay. All right, at this break point here, he illustrates it pretty well up here that that annular ring on the trampoline, which represents a cross section of the spherical waters above. Okay, and he's showing that as the waters above expand to larger and larger diameters, then the speed of the clocks at that gravitational potential will go faster and faster. Okay, so it's the same here. If you have a flat line here, that means that all the mass is out here. If God creates stars and galaxies all along here, then that line will go to slope because there's mass pressing it down. Okay, changing the gravitational potential. Okay, so on the fourth day, God created stars in the firmament between the earth and the waters above, making a slope of a line there. Any part of the slope line that corresponds to the stars below the critical potential will be a timeless zone. Okay, so what? What's significant about that? Okay, let's look back at 14 through 19. God said, "Let there be light in the expanses of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years, and let them be for lights in the expanse of the heavens to give light on the earth." And it was so. God made the two great lights, and the greater lights to govern the day, and the lesser lights to govern the night. Oh, he made the stars also. God placed them in the expanse of the heavens to give the light on the earth, and to govern the day and the night, and to separate the light from the darkness. God saw that it was good. Morning and evening, fourth day. Notice it says it placed the stars in the expanse. The expanse is everything from zero radius out to the waters above. So it's saying that God placed the stars and galaxies He create throughout that radius. Okay, and it would make a slope line out of this gravitational, out of this trampoline analogy. Okay. Also notice that if this was originally flat up here, and God put stars and galaxies, then at the center, Earth and some number of the stars and galaxies will fall into this timeless zone. Time will stop there. They won't emit any light. Won't be light moving. Won't be anything happening. Okay. Also, as he might create these in a wave going out from the center. He could move the critical potential up. Suppose he did it at such a way that as they created stars, this thing's going out. As they created stars along here, this whole thing was depressed. It turned out that this point ended up at the critical potential. So that everything in the universe below the waters above would then be in the timeless zone. Now, suppose they started moving the critical potential farther and farther down. Then the stars out here would start emitting light. It would start traveling toward the Earth. And went down a little bit further, stars a little bit farther in would start emitting light. And so on. As the critical potential, then more and more of these stars would be emitting light, including toward the Earth. Now, suppose he made it go down such that this intersection point here moved down here at the speed of light. Then all the stars, like going in at the speed of light, would all arrive when the Earth popped out of this timeless zone. Do you see that? So all the starlight being emitted by the farthest galaxies and the nearer and nearer and nearer, and then the nearer stars in this galaxy and so on, they would start emitting light as in a radially inwardly pattern, so that it all arrives at the Earth at the same time. If you were on Earth and suddenly popped out of that, you'd all see all light, all the stars, all the galaxies, just like that. That's what would appear to you. And Humphreys is hypothesizing that happened on day 6. Then on day 4, day 3, he created this expanse. He created the stars and galaxies in the expanse. Day 4. Day 5, he created sea creatures and so on, and birds. Day 6, he created man and so on. And Adam needed to look up and see the skies. And here it is. So here is a way, again, to arrange all of that happening in physical theory, derived from general theory of relativity. Now, that doesn't say this is the way God did it, but this is a way. This is a way to have a good start on solving that problem. And most people are thinking there is no way the guys will ever work this out. We got 2 ways. We got 2 real good theoretical starts on it. Lots of questions, lots of details you have to be added. Okay. So here's another diagram that Humphreys often publishes, and it has at times been real hard for me to figure out what does that mean. Well, if you compare it to this diagram, this is the same thing. This point is this point. Okay. This is the expansion of the waters above. And this is, it's like the critical value started down here and it went up to here and then it came back down. All the time, galaxies out here, say, would be emitting light. But things in the timeless zone wouldn't be seeing any of that. So this is simply, here's this radial axis is the same for both diagrams, but this is Earth time on this one, whereas this is gravitational potential. So this is kind of some of the same information, but rotated on the 90. This axis would be perpendicular to the plane of this diagram, something like that. This is cosmic time out here, where that's not shown anywhere in this diagram. So that's how they're related. This axis is the same as this one, and these are simply two different quantities being shown for the same action. Okay. All right. So here are a couple of good resources from Humphreys. I want to talk about Jason Lyles real quick. He is another PhD astrophysicist. He talks about one-way speed of light is impossible to measure. Okay, we'll let you make a case for that someday. He says that Lyles says that only the round-trip average can be measured. It is impossible that the speed in the opposite direction. It is possible that the speed in the opposite direction could be different. Okay. He says it's conceptually possible. You can't prove this either. Okay. For example, it could be half speed going out and instantaneous coming back. That's what he's interested in. I don't know how they can be either, but I'm just trying to be complete in representing what this third line of argument is. Okay. Well, the opposite, of course. Therefore, it could be that light from stars arrive instantaneously. Any light reflected by or sourced at the Earth goes at half the conventional quoted speed of light, 186,000 miles per second. Then we would see the cosmos in real time without any kind of delay. That's a lot of people uncomfortable with that. Then the perceived starlight and time problem would be false. It'd just be imaginary. It would not exist. Note the ancient cultures used this convention. They thought that you see things and events when they happen, no matter how far they were. No matter how far away. Instantaneously, you saw it happen at the same time. Okay, so that's Lyell's theory. I've never run anybody that was comfortable with it. But if you recall what we were talking about Faulkner, it may be that he's warming up to this a little bit. Okay. Dr. Grissom.
My freshman physics book describes two measurements. Measuring the speed of light between mountaintops. They have some apparatus and you could actually generally measuring around trip. So this could be in the Earth's atmosphere. So you have to measure on based on this, you have to make the assumption that even the Earth's atmosphere goes high speed in one direction and instantaneous the other.
I have that same problem. And if you wanted to talk about radial versus tangential or something like that, then maybe, but I have trouble. Mm-hmm. But that's one of the things you'll see in the literature. Yes?
Not only in Genesis chapter 1, where everything's created out of water, we've got 2
also the GHCA information, and it says you got some water and water. And that's not right.
Yeah,
Then there's business
that corroborated. Wait. You said that corroborated it. Which it are you talking about?
Chapter 1 is not the main place talks about members from the north.
Yes. Okay.
Second, I don't see any evidence that the theory of general relativity is disproved. And Einstein came up with it very much like Schrodinger's wave equation that describes particles of atomic particles. If you write Schrodinger's wave equation, on a single line, if you go all the way around the room with chalkboard with so many things on it, the only thing that they've been able to solve, including wave equations, is hydrogen, because it's so complicated. So there are parts of general relativity that still are yet to be, the derivation is yet to be completed. The parts that they have been able to complete predicted the gravitational time dilation. There's a common plot from Denver and Greenwich. So basically, the general relativity, they were able to predict that there would be a difference in time measures for different elevations relative to the center of the Earth. And as I just recall, I think the error that they found in the general relativity was something like 25 that they have.
They've measured those kinds of things very much more precisely, more recently, but those are teeny amounts of dilation. Okay, and the amount it takes to get make a difference to the starlight time problem is a totally different thing. I disagree. You don't have to work with what you got. You can go think about it and come up with some other things. You're right. General relativity has many ways of possibly solving those equations. But what I'm talking about is the conventional way of doing that on which Big Bang is based produces this kind of prediction, yet the measurements of these kinds of predictions. These are huge errors, and that says, under this circumstance, that theory don't work. Big Bang. Russell, Humphreys, and Carmelli modify the usual general relativity quite a lot. Okay, now let me restate that. Carmelli adds a fifth dimension. That's a radical modification. Humphreys uses the general relativity equations and solves them in a different way. Okay, to generate a different theory.
And that's quite about the area where there's no time. The word for that is visualizer. And you get, if you have big enough mass, and you get close enough to it, the closer that you get to the mass, the smaller time. And then when there's some magic point that you get within the visualizer, then you get the visualizer. That was the natural thing where you try to mathematically, you derive a mathematical model to describe the difference in time between creation and next thing is Einstein himself started out with an idea of the nuclear fabric of the universe. Then he dismissed it, and Newton was why he went back to it because it's inconceivable that the Earth could be formed without ether. Basically, the concept of ether is that with the 17 verses where you have the middle stretch, and again, the Bible in 17 different verses was the universe. I think it was more like pizza.
Okay. Let me say something about that. Okay. You've just made a point that is extremely important. I've missed it, that I meant to bring out. Einstein, as you pointed out, started out with ether, and some things drew him away from that, and he came back to it later in life and said it must be there. There are many other things that point to there's some physical structure to space. Now, that is a problem, and nobody knows has got that well defined or anything else. Probably a lot of ideas running around somewhere, but that hadn't dominated anything. That is one of the underlying problems under all of this. Okay, hold on. That underlines all of this, and could be a breakthrough if you figure out some better understanding of that. Next month, Tone Como is going to be talking exactly about that sort of thing. Okay.
Gravity.